Right. Going into the unit circle. So a unit circle is a circle of radius 1 unit centered at the origin. So instead of dealing with that Pythagorean theorem equation last section, x squared plus y squared equals r squared, it now becomes x squared plus y squared equals 1. So on the unit circle, the r side, the hypotenuse is 1 unit. Here are your ratios, your trig ratios when we are dealing with the unit circle. Notice all r's have been replaced with the value of 1. So sine represents the y value, cosine represents the x value, tangent is the ratio of y to x, cotangent the ratio x to y, and then secants and cosecants are the reciprocals of sine and cosine respectively. Never let a denominator be zeros in any equation. Okay, the unit circle is a little overwhelming. It looks very scary. It's on the next page. I've gone over all the different patterns that exist in this unit circle, so make sure you read through the notes because I'm not going to read them to you. So here's your unit circle. Get familiar with it. I'm more concerned about radian angle measures because they are more useful since they are unitless, but you do need to know the degrees. We will be doing a little bit of back and forth. And again, here is where all the patterns are discussed. So go over this to make sure you're comfortable using it. All right, we're going to focus on the radian measures, like I said. So sine 2 pi thirds, basically you need to know what quadrant you're in so that you know what's positive and what's negative and whether you're closer to the x-axis where the x is the long side, closer to the y-axis where y is the long side, or in the middle where x and y are equal. So I usually just do a very, very quick reference guide because I got to see it. So I do a very small x and y axis real fast, and then I draw the angle. 2 pi thirds is in quadrant 2 because the numerator 2 is 1 less than the denominator 3. So the 3's are closer to the y-axis, so our angle is going to be here. Sine is the y value. Closer to y is bigger. Square root of 3 over 2. Square root of 3 over 2 is the biggest ratio between those three. Square root of 3 over 2 is the biggest. Square root of 2 over 2 is the middle. 1/2 is the smallest. When you're closest to the y-axis, y gets the bigger value. All right, B. Cosine 11 pi 6. 11 pi 6 is 1 less than double 6, so that's quadrant 4. 6 closer to the x-axis, so our angle is here. Cosine is the x value. Closer to x, x is bigger. Square root of 3 over 2. Tangent, pi halves. It's not a 4, a 6, or a 3. This is an axis angle. Pi halves is straight up. Straight up is here. So that's where we are. So that is the point 0, 1, if you want to reference it. Tangent is the ratio y over x, but when I do y over x, that is 1 over 0. 0 is never allowed on the bottom. That does not exist. I write D and E. I believe in the homework you will be checking does not exist. The little bullet that says it's undefined or does not exist. Secant 7 pi fourths. Your 4's, again, are in the middle. So 7 is 1 less than double the denominator. So that puts us in quadrant 4. And because it's a 4, it's in the middle of quadrant 4. In the middle, x and y are the same. Square root of 2 over 2. Secant is the reciprocal of cosine. Cosine is positive, so I turn square root of 2 over 2 upside down. So again, for some practice, what I usually do, so let me come down here. So I would write square root of 2 over 2, but I write it upside down because secant is cosine flipped. And then we rationalize, so we move the square root up and drop it on the bottom, but when I move it up and drop it on the bottom, those 2's are going to drop. And that is because cosine already was rationalized, so when we use a reciprocal, it's unrationalized. We don't have to worry about rationalizing it. So square root of 2. Cosecant 2 pi. It's not a 6, 4, or 3, so it's also an axis angle. 0 and 2 pi are in the same location. 0 is no rotation. 2 pi is a full rotation. So this is the point 1, 0. Cosecant is the reciprocal of sine. So 1 over y, well 1 over y, 1 over 0 I cannot do. Does not exist. Three pi halves. Again, not a 6, 4, or 3. Also an axis angle. Straight down. So that puts us here. 0, comma, -1. Sine is the y value, -1. Cosine 5 pi 6, 1 less than the denominator, so that puts us in quadrant 2, closer to the x-axis because the denominator is a 6. Cosine is the x value. When you are closer to x, x is bigger, but it is negative because it's in quadrant 2, square root of 3 over 2. 3 pi fourths, 1 less than the denominator, quadrant 2. A 4, so in the middle of quadrant 2. So we're here. That's where x and y are the same. Tangent is the ratio y over x. Well, y is going to be square root of 2 over 2. X is going to be negative square root of 2 over 2. So your tangents of all your 4s are either 1 or -1 depending on the sign. In quadrant 2, one of them's negative. Secant pi halves, another axis angle, straight up. So we are here. That is the point 0, 1. Secant is the reciprocal of cosine. 1 over x, oh, I can't do 1 over 0. So it does not exist. 5 pi thirds, 1 less than double. So quadrant 4. 3, so closer to the y-axis. So we're here. Cosecant is the reciprocal of sine. Sine is bigger, but it's also down, so it's negative. So y would be the square root of 3 over 2. So I'm going to write it upside down. I then move it up, and I drop it on the bottom, but I keep the negative. So -2 square root 3 over 3. So those are kind of the characteristics you're looking at to figure out the values of these. Closer to the x-axis, the x is bigger. Closer to the y-axis, the y is bigger. And when I'm saying bigger versus smaller, that's because if you look at all those ordered pairs, they are one of these 3. Square root of 3, those, gosh, that looks terrible. Root 3 over 2. Good grief. Over 2, straight 2. Square root of 2 over 2, or 1/2. Those are their decimal values in order. Square root of 3 over 2 has the bigger decimal. Square root of 2 over 2 is in the middle. It's got the middle decimal, and 1/2 has the smaller decimal. Closer to x, x is the bigger one, root 3 over 2. Closer to y, y is the bigger one, square root of 3 over 2. And then the other gets the smaller one. When you're in the middle, they're both square root of 2 over 2. All right. Domain and range for sine. We're not going to do a whole lot with this right now. It's just important to realize there's no restriction on the angle you can plug in. We can rotate around the unit circle positive or negative as much as we want. Any angle fits because the denominator is never 0 since their denominators are always the r value of 1. The range, however, is restricted because they involve x and y. Those are not allowed to be the biggest sides of your triangle because they are the legs. Therefore, the range is -1 to 1 only. That's the biggest ratio allowed to go in, and then the smallest ratio allowed to go in. Some more trig identities. Add this to your list of identities that we covered earlier. Even and odd functions, so that just allows us to evaluate angles if it's not explicitly on the unit circle, but it may be coterminal to 1. So with even is cosine and its reciprocal secant. So what that means is a negative inside is as if that negative never actually existed. We can just drop it because they're going to have the same value. The other 4 are odd. Sine, tangent, cosecant, and cotangent. So sine and its reciprocal, tangent and its reciprocal are all odd functions. So a negative on the inside gets moved and becomes a negative on the outside. So negative inside becomes negative on outside. Cosine and secant, poof, the negative is just gone. And the point in doing this is because coterminal angles start and stop in the same place, which means they have the exact same reference triangle, which means all of their trig values are the exact same. So that's where these identities are going to be helpful. All right, so sine of -2 pi thirds, a negative inside is equivalent to a negative outside because sine is odd. So I'm going to take said negative and move it out, and that's going to become negative sine of 2 pi thirds so that I can put myself back on the unit circle. So 2 pi thirds, not going to worry about the negative until I get sine. 2 pi thirds, 1 less than the bottom, so it's right here. Y is the big side, so right there y is the square root of 3 over 2. So we're going to get negative square root of 3 over 2. (15pi6), that is clearly over-rotated because the last pi6 angle we get is 11. So what we want to do is just get rid of a loop. So we're going to remove a loop from it. So cosine of 15pi6 is going to be the same as if I subtract 2 pi, same as 3pi6, because we took the loop off. And 3pi6 actually reduces to pi halves. All three of those, because they are coterminal, have the exact same cosine value. So that is straight up the y-axis. Cosine x value is 0 here. Tangent negative pi halves. Tangent is odd. Negative inside becomes a negative outside. So I can evaluate tangent of pi halves first and then stick the negative on it. Tangent pi halves is straight up. Tangent is a ratio of y over x, but x is 0. Well, I can't do negative undefined, so it just does not exist still. So there's nothing we can do there. When it doesn't exist, you can't negate it. 9 pi fourths, also over-rotated. The biggest pi fourth we have on the unit circle is 7 pi fourths. So we want to find the coterminal angle by taking away 2 pi, which is going to give us pi over 4. So those two have the same secant value. Numerator is a 1, so that means we're in quadrant 1. And because it's a 4, we are in the middle of quadrant 1, so we are here. So secant is the reciprocal of cosine. Cosine is square root of 2 over 2, so we turn it over. And remember, it's going to just be square root of 2. Cosecant negative 2 pi. Cosecant is the reciprocal of sine. It is odd. Negative inside becomes a negative outside, so we're going to bump it. So negative, and then we can do the cosecant of 2 pi first. 2 pi is straight on the x-axis. That's not very pretty, but it'll work. Here, reciprocal of cosecant is a reciprocal of y. Y is 0. Well, we can't reciprocate, or we can't negate d and e. So it just stays d and e. Cocos are d and e on the x-axis because they involve y, and y is always 0 on the x-axis. Cosecant and cotangent are d and e anywhere along that x-axis. Cosine negative 5 pi 6. Cosine is even. Poof, the negative is gone. It just disappears. So it's going to be equivalent to cosine of 5 pi 6. 5 pi 6, unit circle-wise, 1 less than the denominator, so we're in quadrant 2. Over 6, so closer to x, so here. That means x is the bigger side. It's also negative because we're in quadrant 2, so negative root 3 over 2. Tangent 7 pi thirds, over-rotated because the biggest pi third we get is 5 pi thirds. So we want to find the coterminal angle by removing a loop. And that coterminal angle is going to be pi over 3. Pi over 3, numerator is a 1, so it's in quadrant 1. Over 3, so it's closer to the y-axis. So our angle is going to be here, where y is the bigger side. So y, square root of 3 over 2, over x, 1 over 2. Remember, those denominators are always 2's. They're always going to drop. Square root of 3 over 1 is the square root of 3. Secant 17 pi 6, again, over-rotated because the biggest pi 6 on a unit circle is 11. So we are going to get rid of a loop. So if we take away a full loop, we get 5 pi 6. 5 pi 6, 1 less, quadrant 2, over 6, closer to the x-axis. Actually, the angle we just dealt with. We're just dealing with secant now. So we're here. Secant is the reciprocal of cosine. Cosine is negative square root of 3 over 2. So I always write it upside down. And then that gives me a visual. Move the square root up and drop it on the bottom. So negative 2 square root of 3 over 3. I would recommend maybe do these twice just to get some extra practice with this. And then work on getting that not only the identities memorized, but also the locations of your unit circle angles using those tips suggested above. Let me know if you have any questions when you're going through your homework.